Another late night session, moving to Gas County. We're calling it moving to Gas County because we're looking at Gas City, the orchestrator framework built on top of your computer agent of choice that's going to do all of your job for you, perhaps. Um, but yeah, with you as the leader in command, the head chef of the kitchen, the general of the army. And so, over the last few sessions, we've gone through the tutorials for Gas City, and we finished the seventh one yesterday. And now I think we're looking for how we go about contributing to Gas City. And the reason I say that is that this is one of the best ways to sort of get involved in the community, as well as to try to understand what this thing is made out of. And so we're looking at the documentation inside of Gas City for contributing, and it in turn leads us to lots of other documentation that'll give us a lot of information about how it's built, what contributors need to know and do before they start contributing to the project. And if we knew all of that, if we knew enough to go in and start messing around with Gas City, we'll be able to mess around with our own Gas City, make our own improvements, carry out our own vision for the software, and that's what I'm ultimately looking to do. I think that there's a danger in getting a certain kind of mastery, which has to do with I guess say that like when prompting was coming out, when GPTs were first just coming, were chatbots, not really coding yet, but the secret was the new job was going to be the horse whisperer of this AI thing. And everyone would, write books about, oh, well, if you put just these magic words inside of your prompt, you're going to get much better results. Or if you don't put in such and so guardrails, it'll spin off right away. And um, all of those things are sort of overtaken by events, right? I don't think that anybody would say, we need the horse whisperer now for this thing because the capabilities of the models have kind of outstripped all of those. Um, you could say hacky strategies or cargo culting type strategies. We're really looking for things that are sort of more bedrock, that are more principles based rather than sort of flavor of the month based. And it's hard to say that like any of the knowledge that we learned about tweaking Opus 3 or something like that from a year ago or whatever, uh, it feels like no longer relevant. And so let's look at a orchestrator system, think about which parts of it are essential and which parts of it are accidental. And that way we'll know when we're building our own orchestrator system or when we're modifying this one, like what pieces are truly important to get in there. We'll try to learn what kinds of quality gates. This is sort of a snake eating its tail kind of thing, right? Because one of the ways that you could think about contributing to Gas City is running Gas City on Gas City and making it make features on itself and then deploying it to itself and testing itself. And there's a weird sort of energy that you get when you're writing a project and you're using a project to change itself because uh, if it goes off of the rails, it can go off the rails in a kind of weird spiraling kind of fashion, right? Like if you make a change that really messes up Gas City's ability to fix itself, then if you keep following down that path, you're kind of leading yourself into a dead end, or worse, being deceived about its quality or something like that. Uh, so yeah, there are various strategies that we can use to get around this, but certainly one of them is to we have our own repo of Gas City. We can update it from its fork, like I've been doing periodically right here. So this is my fork, and we're just syncing it from the parent every now and then. Uh, and then when we're building out of that, and we can choose to build out of the main branch whenever we want, so that we have the sort of state of the art or up to date version of the software. But then we could also choose to install our own features and see how they play before putting them back, that kind of thing. So I think this kind of exploratory work with the documentation and with the features of Gas City is just going to teach us a lot about it. So I looked through some of these docs a little bit before getting on. This is the This is sort of the root of the this is where we found the tutorials. If you haven't already gotten your own Gas City going, installation and quick start is probably a helpful place for you. The repository map, I think we're going to see again, we're going to get into. We walked through the tutorials in previous ones. There are certain specific guides. We can take a look at those later, but I think that we're going to be best served by looking into the reference documentation, like this engdocs contributors and engdocs architecture. And so let's look at this one first. Read these first. You can see there's a bit of redundancy and overlap here, right? Like here's the code base map, and here's a different link to the same code base map. Here's a circular reference to contributing MD, right? If we follow enough links, then we're gonna, get from contributing MD to this, that kind of thing. And so this stuff about the API, it's like how should you be able to interact with Gas City? I don't know if we need to touch this so much right now. Maybe let's figure out how it works first, what principles exist in its architecture, where all of the code is, that kind of thing. And then we can move on. There isn't too much else in this document, but let's look at these expectations real fast. Keep current state behavior in the architecture docs and future changes in design docs. And there are also past changes, you could say. Um, so I think a principle here that is not immediately obvious if you haven't worked with these kind of systems before is that you can very easily generate design documentation for new features that you want to do. And you could have that used for future reference, right? So say that you're writing a new feature into whatever software you're doing, and you're like, okay, I'm going to create a docs folder. I'm going to put my design doc in there. And then once it's been implemented and everything, then this will be the record that was shipped with that code change that anyone could use to go, okay, this was the motivation for this feature, and this is the sort of historical reason why it was built. Um, and that's useful information. That's useful context to have. But if it's ever superseded by some other behavior, then it starts to become deceptive to any agent that would read that document. You don't want to have two conflicting documents that describe two different sets of behavior, or describe a historical behavior and then a current behavior. That gets messy. And so what you want to do is kind of archive whatever architecture changes or feature changes you made that have been superseded. So we've got current state behavior, future changes in design, and then I would say also we would add maybe past changes into archive or something like that. Second, treat the primitive test. It appears here twice as the gate before adding new SDK surface area. We'll probably take a look at this. Run make check before you open a PR. Always a good thing to do, and you might want to create a Git hook around this, right? Like inside of Gas City before you push changes or something like that. Make sure that make check passes. Run make check docs when you're changing documentation or that kind of thing. Let's look at primitive test first. Whether a capability belongs in Gas City's SDK primitive layer or in the consumer layer. And the consumer layer being like things that are customizable by the user or by the governor of Gas County, if you want. All right. A capability belongs to SDK only if all three necessary conditions hold. Can agents do it safely without races? Why is this important? Um, so, um, this concept, I think, for those unfamiliar, what is a race? Why do we care about races? Um, Here we're talking about when two agents or two processes of any kind are working on the same thing. Perhaps they're both looking at the same piece of data, or they're both working on the same pool of work or something like that, and they both do something at roughly the same time, right? And how long the window is of doing something at the same time really impacts how likely it is that they'll sort of collide with each other or interleave their operations with each other. So, for example, if you have a process that's really complicated, say like one of our long-running formulas that calls into multiple agents or creates some research and then acts on that research and then finally creates a PR, a pull request, right? If two agents are doing that at the same time in the same workspace in the same context, right, then they can step on each other's work. Like for instance, the first agent could write a research document, and then before it starts to read that research document, the second agent could also write a research document. There's no guarantee that their research documents will be compatible. Perhaps they'll contradict each other. And so the next step in their process will read the wrong information, or it won't be able to work on its feature because it's been overwritten or superseded by something that the other agent is doing. And this one is so corrupting state or violating invariance is a particularly pernicious version of that. You could imagine that there was some resource that was so vital to keep consistent, such as, for instance, like the beads database, like we were talking about, the list of all the work that's ever been done inside of the city might be an example. Um, you know, that kind of thing. And so we want to be sure that we're not corrupting the state or the database in that way, like causing causal imperfections, for instance. Say, like, if we're recording a chain of events and one agent could rewrite the basis of one of those events out from under the other one, then we'd have a sort of, if we looked back at the history of that chain of events, we'd have a sort of broken timeline, might be an example. And so a lot of whenever programmers encounter this concurrency, we're looking for ways to kind of prevent invariant violation or state corruption, data corruption, that kind of thing. Um, and so this principle is trying to say that the SDK must do an atomic thing. If it's a single agent operation, naturally idempotent, meaning that if you do it twice or any number of times, the same result will follow. Or the underlying tool already handles concurrency, then agents can call it directly. So let's talk about this for a second too. This is another way to sort of combat the problems with concurrency, which is say that we have two processes that both pick up the same piece of work, and then they both want to take a similar action at roughly the same time. So that, for instance, one sees a transaction in a ledger to write, and it picks it up, and then it wants to say deduct $50 from your bank account. You don't want a second agent to come along, see the same looking transaction, have them both working on it simultaneously, and then have two deductions for the same essential transaction. And making things idempotent or making transactions idempotent means that you can recognize when they're duplicates. You can perhaps use a natural key for them, like often a transaction ID, or perhaps a combination of attributes that make it so that the individual causes can be sort of uniquely identified. And you can use that unique identity to tell, has the work already been done for this thing? And a step further, like if the work has already been done for that thing, then the second one, say that we're doing our $50 transaction again. The first payment gets written down, and then the second one could see that that was written down, and instead of failing, it could just silently succeed. And it would return, instead of new information related to the success of writing down that transaction, just the same old information. And that what that does is it prevents processes from breaking. It allows for you to have multiple agents processing the same thing and not stepping on each other's toes or, you know, destroying your wallet or your data store or anything like that. but instead only doing things at most once, where you see that kind of unique identity or that unique cause to produce like a unique effect. Can two agents hit this simultaneously? Does underlying tool, beads, git, tmux, the terminal multiplexer, already provide atomicity? Is there a read, check, write pattern that could race? So this is sort of a classic pattern, right? That says something like, uh, again, using this sort of $50 example. Say that you have maybe $75 in your bank account. So if the first one reads $75, and it checks to see if you have enough money to do a $50 payment, then it will succeed and it will start to write down that change. If a second thing picks that up and is able to see into that process, say like it would read $25, say that the write had already happened, and then it would check to see if you have already spent that money. uh, you don't have enough money to make the payment, and so the second time through it would fail. And so that's the sort of the weird kinds of things that could start to happen if you have multiple processes reading the same thing, potentially getting two different answers, and then running two different sets of behavior at the same time. Uh, and then, of course, like interleaving writes and other weird stuff could happen. Uh, so this is talking about certain implementation details of Gas City that do basically you know, follow this pattern of atomicity because they are doing certain SQL operations in the database. Uh, this seems to be a problem. And then needs to be atomic. I'm not sure what abbreviation they're using there. Two agents hooking the same bead. That would be like two people are processing the same work at the same time. Uh, Gas City's bead store claim provides this. When the underlying store, I guess like the fileback store, or we looked into other different ways that you could store beads besides like the Dolt database that might provide that atomicity. Okay. Second, the bitter lesson. So we're talking about the three necessary conditions for putting something into the SDK. Does it become more useful as models improve? This might be a good digression. Let's start a new feedback document here, and we've been writing down feedback for our various readings of the architecture. Well, let's say contributing in general. We have a series of feedbacks inside of the tutorials. We wrote down things that seemed odd, with the intention that we're going to come back around, and once we know enough to kind of check through the issues or criticize the documentation, then we can potentially create some issues and go and fix some of these issues inside of the Gas City documentation. And I think some of these are valid regardless. There's nothing that's going to change the fact that this first tutorial used a bunch of words that were undefined at the time they were used. And that's just going to be like a problem of first impression forever until it gets fixed. But some of these other ones, it's like, oh, okay, well, there needs some reorganization needs to be done, but maybe what was lacking was just my understanding. And that might supersede some of the feedback that we have here. All right, let's begin. Primitive test. So I happen to have read the essay that this is built on. The second prong here, the bitter lesson. And we can go look at the bitter lesson. It's publicly available. It's I think, very important and interesting. Uh, and here's the essay itself. We'll put the link in. Um, but Good link, better lesson. Should link to the paper. It's pretty short. There's no reason not to put this link into the documentation. Um, let's take a short digression and read this. Look, no one is from 2019. So I think that the interesting thing that we can learn from the bitter lesson, it has to do with maybe the failure of humans to predict what would be the best way for a computer to solve a problem. And that has something to do with, as you can read in the essay, as you can learn from the history of artificial intelligence, especially classic approaches to artificial intelligence. Um, there was definitely a long period where humans were trying to implant expert knowledge into a computer, and then knowledge of those human features would help the computer to get human-like performance. And so an example might be, um, while we were teaching humans or teaching computers to get good at backgammon, um, it might be faster if we just implant certain expert knowledge of backgammon into the thing. For instance, uh, we might give them a sort of a higher level feature of a wall, which in backgammon is a series of groups of two pieces that block any pieces behind them from advancing. Because if you, in backgammon, you're trying to move your pieces around the board, and the other player is trying to move their pieces in the opposite direction around the board, and you can block each other. And it's interesting to consider game states where that's happening. And if you can recognize that quickly, or the potential for that, then that might speed up your understanding of what's going on the game board. Uh, but uh, Leveraging knowledge. But over a slightly longer time than a typical research project, massively more computation inevitably becomes available. So this is the sort of weird thing that started to happen, was that somebody could spend a really long time on trying to implant expert features into a program, and then by the time they were finished, all of those gains would be swamped by the ability to just run the same old program on better infrastructure, like adding more CPUs or GPUs or memory or that kind of thing. So it goes through some examples of that, like chess. Yeah. So it was looked upon with dismay by the majority of computer chess researchers who had pursued methods that leveraged human understanding of the special structure of chess. However, the simpler search-based approach with special hardware and software proved vastly more effective. You know, uh, and so it wasn't how people played chess. And not only that, it's not something that people could learn from, right? Um, because we don't have specialized hardware to memorize the book of endings or the book of openings. We don't have specialized hardware to look 20 ply into the future and this kind of thing. Um, they wanted methods based on human input to win, and they were disappointed when they did not. And I think a little at odds with reality. They were at odds with reality when they saw that this quote unquote brute force, uses a pejorative method, was the winner and that others didn't. And so, similarly for Go, uh, learning by self play and learning in general enables massive computation to be brought to bear. And people are always looking for problems now where massive computation can be brought to bear because they've learned the lesson of this thing. They've learned that we're going to continue to get more compute, or we're going to continue to get um, just more hardware. We should be concentrating on things that are going to scale in the future, instead of sort of hand tweaking human knowledge and special features. Um, here, another example. There were lots of examples, but this one I think is super important. It has to do with human language, understanding human language, and there's a lot of different features to language, things that you'd never thought of. Um, you know, all the way down to the letters and all the way up to, through words and syntax and sentences to discourse and intention, meaning and semantics. The stack goes really high up and really far down, right? If we're just talking about even how sounds fit together when you stick them next to each other. Um, yeah, just a whole lot of information. And linguists or people who studied language, uh, they had learned a lot and they had found a lot of patterns. And obviously, they were trying to use all of the special stuff that they had learned in all of these various dissertations, thesis. And they thought, well, if I teach the computer all of this stuff, it's not just that that will teach it language, but it should give it a leg up, right? It should be better. And in fact, it turns out to be worse. Statistics and computation came to dominate the field. Um, Google, in particular, doing a lot of translation based on statistical analysis of like UN translators translating a statement into many different languages all at the same time. It's a public corpus. It's a unique body of work that is sort of like a Rosetta Stone for the computer. And you can keep on creating this corpus, and it'll keep on learning patterns the more that it reads. Um, yeah, deep learning. Sort of like, I think the short version of deep learning is that it's finding patterns and patterns and patterns. Um, but yeah, even less on human knowledge and even more on computation. Yeah, the researchers were trying to do human minds inside of computer brains. Ultimately counterproductive, a colossal waste of time. And all of those methods got superseded. And similarly in computer vision, we're looking for special features, we're looking for primitives, trying to give the computer a leg up. And they do better. This is a big lesson, a bitter lesson. We keep making the same kinds of mistakes. Building knowledge helps in the short term, but it plateaus and inhibits further progress. And breakthrough progress arrives by scaling computation. Yeah. And it's sort of like trying to do it the human way, if you want. And not just the human way, right? Because human brains are incredibly complex. Potentially, there are quantum effects going in our brains. We don't understand everything that's going on up here in a very detailed way. Um, Even when we try to model a human brain into the computer, uh, there are mathematical constructs called neural networks. It's sort of a poor shadow of the real thing, right? And I think that's a temptation, right, to say that we know ourselves enough that we can put that structure into a computer and run it and expect it to perform exactly the same way. So, two methods that seem to scale arbitrarily: search and learning. I think to this we would also add lately attention, right? uh, in the sense of attention being all that you need in these transformer networks. The second general point to be learned is that the actual contents of minds are tremendously, irredeemably complex. We should stop trying to find simple ways. And I think this is an interesting lesson for us because I think that the software engineers' instinct or sense after long years of expertise is that to favor simplicity, right? And simplicity is good because it makes the system understandable, maintainable, um, perhaps mathematically beautiful, perhaps getting to the core of what we care about it. Um, right. But uh, perhaps these things that we're talking about, space objects, multiple agents, symmetries, are intrinsically complex and arbitrary. Uh, we want AI agents that can discover like we can, not which contain what we have discovered. Building in our discoveries makes it harder to see how the discovering process can be done. It's like giving AIs human colored glasses, right? Okay, that's the bitter lesson. And so the bitter lesson, I think, in this context, let's return to our documentation. If a smarter metal model would do it better from the prompt, then it fails the bitter lesson test and it belongs in the consumer layer. If it's pure plumbing that models would always want to delegate to, it is a primitive. The test. Imagine a model 10 times more capable. Does this capability become less necessary or does it stay necessary? And I think this is a good way to think about our AI tools in general. So I got on this soapbox, I think, in another video, so I'll keep this brief. But basically, we cognition is expensive, and even though we might have a model 10 times more capable, that doesn't necessarily mean that the capability is less necessary. It could also be less costly, right? uh, and so if the primitive is going to save us a lot of cost in the long run, a lot of cognition, a lot of Opus 4.7, 5.0 model time, uh, then we're going to want to keep it around so that it's always a building block that's always available, that is predictable, deterministic, um, understandable behavior. And we could also talk to you about kind of the Unix model of executables, right? Um, Unix being like the operating system that Linux is based on, that Mac BSD is based on. Um, and the principle there is that we should have a lot of small composable tools that have one job, do that job really well, and then they're just not going to get replaced, right? Git is also based on this principle, right? It's the distributed version control system. Nobody is going to reinvent that wheel. It's just we're just going to build on top of that wheel and run our cars on top of it. Um, but it will stay. Um, so, does it become more useful as models improve? Plumbing is good. Anything that's about judgment should probably just be in the model. Detecting which agent should handle a task. This is a very interesting one because it has something to do with dispatching, describing tasks from a problem point of view, but then picking which agent should do it from a solution point of view. So this is something that we can get into later. Um, this is a primitive, creating Git work trees. Things that you could imagine making into deterministic commands or skills. Um, those are the kinds of things that you could imagine if they're universally helpful inside of this context of Gas City. Maybe they should get pushed down into the project itself. But things that are optional or customizable, configurable, should probably not be pushed all the way down to the project. Should live up where the county governor is making those decisions. There's some other interesting aspects of the bitter lesson, I think, but let me see if I can articulate that really fast. Um, there are certain things that we expect to improve over time, and I think that Gas City is an attempt to stay on that curve, right? To improve as our models improve. And another reason why this work I found so important is that uh, the orchestrators and the agent models and so on, they're open source. There are versions of these that are running several months perhaps behind like the frontier models. So you could say that like uh, we're just about to like an open source version of Opus 4.5 or something like that. Like the model that first sort of blew my mind and started doing significant portions of my work. Um, and publicly available, generally available. Um, you need a certain like amount of like compute, GPU memory to actually run it. uh, but there's like service providers that will do that for you, and that means that tools like Gas City are going to come down into reach of people who just have a computer, who don't need to pay $100 a month or whatever, and that means that they'll be generally available, not just to the sort of privileged few. And so it's important to learn about this stuff right now because um, the bitter lesson, if you want to learn it, is that today's frontier models are going to be like, um, you know, every person capable in several months. It's sort of a race that will never catch up, right? Like the frontier models will always be better than the best open source, publicly, generally available models. But you can either take the point of view that that difference is really significant and it's going to remain significant forever, or that it will plateau at some point, and that a consumer model with a Opus-like agent that can talk to you, understand what you want, can do long-term planning, can create projects for you. Um, some open source model at some point, maybe this year, is just going to be good enough that anybody will be able to use it long into the future. And a model like that that's good enough does mean a kind of sea change for the industry, not just for companies that have billions of dollars to throw at data centers or whatever, but for the average engineer, for the general software firm. And so learning this stuff now is a way to stay on that curve. It's a way to pass the bitter lesson test, if you want. To sort of believe that we are going to have the computation, the scaling, and start to include the cognition that it takes to make these tools really like state of the art and generally available, not just for the privileged few. And so the more that you know about this, the better you're going to be able to use it as that comes out. If you believe that story. If you don't believe that story, then maybe all of the compute's going to get locked up behind a castle, and you're going to have to, go buy it from the king if you want some. I don't know. But I tend to believe the first version of the story. Okay, ZFC is not defined here, but there is a post about it, I think, in the work of our friendo Steve Yagi. Let's see if we can find it real fast. Hmm, maybe not. Here we go. There we go. Okay, so this is an older one from October. Um, and it should link to this too. Here, let's put in this feedback. Should be defined and link to the blog post. All right. We don't have to read through this whole 9-minute read, um, but um, Zero Framework Cognition. Don't put cognition into the framework. Separate out the cognition from the plumbing. And this is if you read one sentence from this is it. When we reach a decision point, go to the model. Don't do it on the client side with regular expression matching, which is a way of, sort of like keyword matching. Let's look for finished, done, or complete. But they could just actually, send it to the AI to read it and understand it instead. So, um, Zero Framework Cognition. This application is pure orchestration. Build a deterministic shell around AI reasoning with strong guardrails and observability. So pure orchestration is great. IO and plumbing, safety checks, policy enforcement, mechanical transformation, but no local intelligence or reasoning. Don't write code that is doing a model's job, right? And this is very similar to the bitter lesson, right? Don't write human features to do a robot's job, right? Semantic analysis should go to the model. Planning, composition, and scheduling should go to the model. Although this is interesting, like certainly like once you've set up all the dependencies and ordering and so on, then you're kind of doing deterministic plumbing to decide what's next or what's available or what's the long pole or whatever. Um, Opinionated, heuristics, you know, yeah, gather raw context, get decisions, validate, and then execute. So that's zero framework cognition in a nutshell. But yeah, don't do cognition in the framework. Pure data movement, process management, or file system operations. So yeah, very you know, very much an overlap with what we're talking about here. Decide on a strategy, detect stale hooks. That even goes out to cognition. And cognition here, like sources of cognition inside of Gas City, the most obvious, the most prevalent one is the mayor. But it might be delegated to some other agent that you have running inside of your city that has some expertise in that the mayor might delegate to. A lot of this whole thing, a lot of Gas City is about delegation, right? It's about a human delegating to these cognitive agents, but then those cognitive agents should probably delegate to other cognitive agents too. Um, this is sort of what the polecat concept is. It's like a very simple, just do my thing for me. Um, don't ask questions, just execute and then send back your response or close that beat or whatever. Cool. When to fix upstream versus wrap. So, for instance, they're talking about how Gas City is built on top of other executables, such as beads. Uh, and if there's a problem with beads that has leaked into Gas City, you probably want to fix it in beads. But I guess the software engineering principle here has to do with a lot of different topics came to mind. Sort of the encapsulation of a module, the principle that one module in a software system should have a well-defined job and that it shouldn't try to do a bunch of different jobs. Um, Things shouldn't leak outside of its abstraction boundary. Um, Modules should be cohesive and loosely coupled, communicating through well-defined APIs. And so that kind of means that sometimes there might be a problem with the way that Gas City calls a tool. That has nothing to do with the tool. The tool is kind of inside of its own frame of reference, doing exactly the job that it thinks it should, and that would be a Gas City problem, right? Um, the tool is correct, but something else needs to happen. Okay, so this is the primitive test. And again, it's sort of about where we want to make changes to Gas City. And so hopefully, if we understand this, um, we'll be able to understand where to put our cognition. We'll be able to understand whether it's necessary plumbing that are primitives that aren't going to change as models improve. And then we're going to understand about whether these operations can be done concurrently, because we're moving into an environment where there are lots of agents doing things at the same time. Okay, cool. So we started with the primitive test. Let's see. Yeah. So one down. Let's do at least another one. I think that the architecture overview is complex, and we might have to spend like a couple of sessions on it. But let's try here. Start with the overview, then dive into the subsystem that you need. So there's a glossary, apparently long-ish. We might return to that, or we might, pop in at the end and see if we've covered everything inside of it. Let's go to the 9 concepts overview. Gas City has 5 primitives and 4 derived mechanisms. All these primitives are necessary to build a multi-agent orchestration system. This is a strong statement, I think. It has something to do with whether knocking out one of these principles, you have to replace it with the equivalent to do a multi-agent orchestration system. Yeah, it's interesting. Let's make a note of this. And don't worry, I had a bold statement. Is it impossible or just different? I think it'll be a useful sort of exercise for us readers to see if we can remove one of these primitives and still build a multi-agent orchestration system that convinces us that it would work. And here, let's get that link. Yeah, because this sounds almost like mathematical. uh, you know, if you read about, say, the foundations of mathematics, or the sort of axioms that we've created our modern mathematics on top of, say, of like set theory or something like that, um, you, you start running into these things where you're like, oh yeah, these really are pillars, and doing away with them really cripples our ability to use this mathematical system to write proofs and do the kind of math that we want. And it's obvious that that is happening. This, I think it's going to be a little bit less mathematical. uh, yeah, another example might be Euclidean geometry, right? Like, you know, Euclid could find these axioms of geometry. Um, the interesting axiom of that triangles add up to 180 degrees, uh, or this it's interesting how that parallel postulate. I guess they're kind of equivalent, but yeah, parallel lines never meet, for instance, is like Euclidean geometry, but there are non-Euclidean geometries where they do actually run into each other. So you could have like geometry on a sphere or something like that, and it obeys different constraints than Euclidean geometry. And we got non-Euclidean geometries, that kind of thing. Anywho, every derived mechanism is from the primitives. We can check on that too. We can try and verify that statement. And each of these 9 concepts is going to be mapped to their implementations. Let's go. All right, we just read through the primitive test. Let's see if we understand. No, this is not the same thing. So atomicity in the primitive test document was about concurrency. It was about whether multiple writers at the same time would run into each other. Um, so this is much much different statement. This is a very different statement than the one in uh, the primitive test document, which links atomicity to concurrency concepts, not irreducibility. So yeah, another sort of idea of atomicity, right, has to do with whether something only functions as a whole, whether it can't really be broken down further or simplified further. Um, yeah, so something odd is going on here. It's like the agent has understood this word in two different ways, and I think that one of the benefits of making up new terms like zero framework cognition or something like that is that they only have one definition. You can't get into this kind of uh, mixing up of synonyms and mixing up of concepts. Um, but it's true. I mean, we shouldn't add a primitive that we can build out of the building blocks that are already there. Absolutely true. But this isn't exactly what I was talking about. If I had to guess, I don't know which one came first, the atomicity in this area or the atomicity in this document. Uh, hmm. We could probably figure that out from the Git history, but not that much more important. Okay, bitter lesson. Does it become more useful as models improve? Um, yes, this is pretty much what it says in that document. Does Go handle transport only with no judgment calls? Yes, this is pretty much what it says in that document. Okay, primitives. We've got sessions, we've got tasks, we've got the event bus. We saw some references to this in previous sessions. We didn't know what it was, but from our experience with other systems, we could say that it was sort of like an immutable record of everything that was happening. Append only, right? Yeah. Append only, another name for sort of like immutable record. Appending is when you just add to the end of something, and if you can only append to something, then it just grows over time. Right? And generally, it's just growing forward into the future. So it's like it says, the sequence is monotonically increasing. So that provides a ordering of events as well. Although there are some sort of weird, interesting things about trying to get a distributed system to agree about what time it is or what are the orderings of events. So there's some interesting stuff there. All right, config prompt. Okay, interesting. So 5 irreducible primitives. 5. I'm not sure why they're called layer 0 or 1. It doesn't say which ones of these are layer 0. Which, okay. Maybe everything's a bead. Maybe that's layer 0. I don't know. But yeah, we've got sessions. Um, so there are lots of different kinds of sessions, but the basic idea of a session is that it's the interface between an agent and Gas City. Session life cycles, agent behavior. Yeah. This primitive was named agent protocol and exposed an agent-agent handle until commit whatever. The interface was removed and responsibilities live in internal session, internal runtime. I think I mentioned this in a previous talk that agents, when you ask them to rewrite documentation, will sort of leave these sort of errors and infelicities in the document when um, it's questionable if you really want to know this. There's like a small group of people that remember that this primitive used to be called agent protocol, and maybe it's better to put that in a historical section and leave it out of this. Um, let's put that in here. Feedback. Leave out of this document. Start, stop, prompt, and observe sessions regardless of provider. Identity, pools, sandboxes, resume, and crash. Crash adoption? That's an interesting phrase. I'm not sure I understand. But I think that it would have something to do with handling crashes. uh, interesting. So, identity, we've learned about this in some of the previous tutorials as well, right? Like, we have different agents that we might be able to sling work to, and they might have different agent prompts. They might have different handles or names, functions, that kind of thing. Uh, and so, yeah, they have their agent name, and then they can sort of react accordingly. Pools, I think we were talking about this. We read a sort of passing reference to this in terms of like pooled work and pooled workers. So this has to do with creating like work queues and having consumers pull work out of those. And you generally limit the amount of resources that you're consuming at one time by limiting the size of the pool of consumers, for instance. So I only mm, handle mail messages that need to be mailed with a limited number of workers. And so you're kind of gating the amount of work that can be done. If I get a bunch of mail to mail, then I could scale up that number of workers briefly. They could work really hard, and then I could scale them back down again so that they basically so that I don't have big piles of workers sitting around and doing nothing for most of the time. I have a small number of workers that are available to handle sort of nominal load, and then I scale them up when I need more. That's what this is saying to me. Sandboxing. Lots of people are talking about agent sandboxing. It has to do with the idea that you don't want an agent to be destroying your database, but you do want them to be working inside of their own cordoned off area where they're free to sort of shoot themselves in the foot or rewrite all of your code base without really affecting your day. Um, I don't know if that's still a thing. I don't know if that's what it's actually talking about. I guess we'll learn more about sessions as we get into perhaps this detailed session architecture document. So just first impressions. Runtime provider. So this is like how to talk to Claude or Codex or Gemini or something. Internal sessions for bead-backed life cycles and naming. That makes sense. And I think that we'll learn the most when we actually dig into the details as well as like go and look at the code itself. Although it is sort of a moving target. I don't, this um, interesting. Yeah, so this docs fix only went in like 10 hours ago. Okay, moving on to the next primitive. Beads. We've talked a lot about beads already. It is a standalone project. It allows you to create work units that have parent child and dependencies and labels and queries. And the benefit of them in the large is that you can define a really large project and then you can have it worked on in small pieces. And the project progress is tracked carefully. It's atomic to get your next work, update them, assign them to yourself, work on them, close them. Um, yes, and then everything else is a bead, a certain sort of bead. Um, Molecules are workflows that are made up of a dependency graph of beads. Uh, Individual tasks are beads. Mail are also beads because they're sort of stored and tracked forever. Convoys would be groupings of beads. Epics, another sort of grouping of bead. I guess I don't really know the difference between a convoy and an epic anymore. In traditional task tracking systems, like Jira, for instance, an epic is kind of like an umbrella for a bunch of different tasks. And when the tasks are done, then the epic is done. You can kind of track progress on the epic by seeing how many of the tasks have been finished and that kind of thing. And so it's useful for tracking. It feeds into some of Jira's agile systems and that kind of thing. But yeah, in this context, like Convoy, which is sort of arbitrary group of work, arbitrary group of beads, it seems like it's doing a lot of the same job. So on reflection, I'm not sure. Um, is an epic just a kind of a convoy, or does it have some special behavior or some other deeper meaning inside the system? Yep. We've got a bead storage system, and the BD store is for production, Dolt backed. We have this file store, in memory store, and this like exec, which I guess is you're allowed to provide your own implementation. So the universal persistent substrate, all domain state is flowing through a single interface, which is cool. And it allows you to look at that interface or like monitor it and perhaps see everything that's going on in the city. Not just the work that you have defined or that the agents have defined, but all of the agent activity and all of the agents themselves and that kind of thing. Okay, we mentioned the event bus a little bit. We have this pub sub log of system activity. Uh, let's see. A critical bounded queue for infrastructure, and optional fire and forget for audit. So I guess the reason that we have a critical tier is because there are some events that we need to know are going in and respond to. There are other events that would be nice if we had them, but they're not necessarily going to cause further chains of events. At a guess. Again, we can get into it a little more by looking at this detailed design doc. Latest sequence. We're maintaining a monotonically increasing sequence. It's interesting that this is going into a JSON-L file as opposed to a stronger data store. Config. We've looked at a lot of TOML files. We've looked at the TOML definition. I advise that you go and look at that if you haven't already. Very simple to understand. What does this markup language give you? Let's see. Progressive activation, level 0 to 8 from section presence. I don't think that we know what this means. Um, let's see. Layers. So we've got layer 0 to 1. I'm just going to be a stickler. It's not obvious from the documentation. Like when we think about like the layers of networking, say like computer networking, um, they're very well defined from the hardware up to the user land, and they have common definitions at each layer and that kind of thing. There's probably like an RFC that details exactly what each layer means. Um, we did look at certain things like in orders. We complained about a different document that talks about how certain orders override other orders. For instance, like the definition of an order, the most specific place, like a rig based order, like a rig configured order, it takes more precedence than one that's defined up at the city level, or even one that comes from a pack. which is like a collection of injectable configuration, if you want. But this level 0 to 8 does not defined. No clue what numbers refer to. All right. Config gets loaded at the city level, the agent level, the rig level. Provider spec, I guess I don't know what kind of config that is, but I assume it has something to do with the fact that I've chosen Claude as my cognition provider. Or other people might use multiple cognition providers or something. And then packs. Config is the feature flag. Adding sections activates capabilities. I think this is a certain philosophy about turning off and on configuration. Um, Feature flagging is a way of configuring that is consulted at runtime, if you like. So, for instance, if I want to run an experiment on users and I want 10% of my users to see a new feature, I might define a feature flag, and then 10% of the time that a user encounters it, they'll see the new feature. And there are various like third-party businesses that will provide this capability to you. And so they're saying in this section, I suppose, that they don't want to have that level of conditionality inside of the configuration of a city. They don't want you to be able to sort of turn things on and off like that. They don't want to deal with dynamic runtime configuration. Maybe there's no good time to go and recheck the configuration to see if the city has been reconfigured. Although it seems like on a tick, you would want to, like every 30 minutes, you would want to go see if the config had changed, and if so, then react accordingly. But yeah, maybe that is a barrier to understandability. I mean, I think that's certainly a problem in, regular real world situations where you have this kind of configuration. Um, is that it's hard to perhaps tell whether a certain set of behavior happened because of a feature flag or not. There could be overlapping and conflicting feature flags where one turns on some behavior, another turns off some other behavior, or those two experiments happen at the same time and somehow collide with each other, or make conflicting assumptions or something like that. Um, Oops. Somehow I hit overwrite. Didn't notice. And another reason why we might see stuff like this in this kind of documentation written by an agent is that the agent might have everything in context, right? It might know what it's talking about, and it has to decide which parts of its context to provide as assumptions and which parts to just leave out as sort of given everybody knows this information. And whenever a person is writing a document for an audience, they're trying to locate like what is the shared level of assumption that we have so that I don't have to repeat anything sort of below that line. And I can just move on to talk about the things that are going to be interesting or insightful or relevant to this topic at this level of abstraction or for this audience, right? And so they don't seem to be very good at that. They don't seem to be very good at saying, like, imagine that Dan, who has never read the other engineering documents or doesn't have, 5 books about Gas City stuck in their head, is reading about it for the first time. Does this make sense? Is it a well-founded statement? Given all that I've seen before. If it's not a well-founded statement, Can I provide a reference to something that would make it well founded? Can I leave it out and put it somewhere else where it might belong? Uh, for instance, it might belong in the config system document. Like there might be some like level confusion with this section and the a level of abstraction that it's trying to give me, and all the details in here that got needed to get kind of condensed into this section. So maybe level 0 to 8 in the config system document. It's well defined and it makes a lot of sense. But up here, yeah, without any sort of like frame of reference, it's not making sense. Prompt templates. Defining what each role does. Behavioral specifications. Yeah. All role behavior is user supplied configuration. I think that makes sense to me. Um, there's no reason for there are certain defaults that you get from Gas City, like the default agent. You're an agent doing work. Do your work and then get out. That's kind of a definition of an agent if you want. But all of the customizations that you might want to do, all the interesting things, uh, you know, especially if we're interested in, as I've talked about briefly, like creating institutional knowledge, creating a sort of software firm inside of a gas city. Uh, One of the roles in that thing is not going to be static, right? It's not just going to be inside of a static prompt, but it's going to be like, you know, these are the things that you're supposed to be good at. These are the tools that you're supposed to be conversant with. These are the say techniques that are supposed to be top of mind when you're solving problems. Here are references to the knowledge base that you can use. Um, Here are the things that you should focus on. Those are all things that in real life with people, as you get better at your job, you expand your repertoire and you expand your documented best practices and your tools and your shortcuts and that kind of thing. And so having them inside of a static mechanism like a prompt template doesn't sound quite right, right? Because a prompt template is more like a job description, if you want, but they're very like vague and high level. And over time, inside of a software firm, a team that's doing a certain job is evolving into the sort of team that does that job well, right? And it might acquire new jobs or it might expand into horizontal area that's close to what it's already doing, or it might get a new job that leverages its existing expertise or something like that. Um, and so they need to continue to grow, especially as they succeed and they gain a reputation, do more work, that kind of stuff. Okay, derived mechanisms. Cool. We learned about mail and nudging. Nudging is like one-shotting messages to an agent inside of Gas City, and mail is like sending a durable message to an agent that is going to be stored in the bead store. And so, yeah, yeah, I think this makes sense. Like messaging, yeah, goes to the bead store with mail, and nudges just go to the session. And the only thing that's special about mail is that it's a bead of type message. It's going to be sent to a certain person or a certain agent. And similarly for nudges, they're just going to get sent to a certain agent. Okay, formulas and molecules. So, if you missed one of the earlier videos, we do talk about formulas, which are sort of the term inside of Gas City for workflows, which you might think of as like a series of tasks that depend on each other. That once you start the recipe, if you do all the tasks in the recipe in the right order, then you say like each task that's available might produce a certain output that's used by tasks further down the line. And when you get to the end of that, you'll have like done a complete thing. So formulas are the templates for those workflows. Molecules are the ones that are where each task, each node in that formula in the workflow gets its own individual bead. And then a wisp is a ephemeral molecule where there's only one bead task written for the entire workflow. And then orders are ones that have uh, it's sort of like at a certain time period with a certain repetition or interval on a cron schedule, go and trigger a formula or a shell script or some other thing like that. So they could have included in here formulas and molecules and orders. They probably should have. So we're still inside of 9 concepts. Yeah. Weird to leave out orders. From the title. Heading. Sorry, just a few hiccups here tonight. When I run out of water, that's probably my clue to be done for the night. I think we're almost done with this document. Let's at least finish this one at this level. It's interesting that it's calling this a proof, but yes. Formulas are out of config. That's true. Um, molecules are the instantiation of formulas into the bead store. Yeah. Same. Molecule and TTL and garbage collection. Now it's interesting because TTLs and garbage collection are not themselves listed in our primitives list. um, let's see. Let's see what we can do with that. I don't want to be too like incredulous. It was really on a roll, and it kind of you know it was almost linking everything back to a primitive, and so this one kind of stands out because it doesn't, right? Uh, formula was just referred to. We've got the event bus trigger evaluation and then config scheduling. Yeah, I guess I buy that one. No new infrastructure is needed. I think overall this section was more convincing even than the other ones, probably. Well, I mean, I like the messaging section was just fine. Okay, dispatching or slinging. This is an interesting way to think about it um, because slinging, it's sort of like you have this work and then you have a target for that work. And dispatching, I think of more in the sense of like in general in software engineering or in like say like on call, which is like the collection of tasks that one has to do to keep the lights on, to keep software running, to answer user requests, to fix errors, to respond to alarms, that kind of thing. Um, dispatching is finding the right person or finding the right agent to do the work, but slinging is sending that work to that agent. So it's decision, dispatch decisions is one thing, and then slinging is another thing. Okay, so let's see. Finding and spawning an agent, a formula, a molecule. Um, so you sling work to a certain agent. This is the nature of the work here. And then that work gets on the agent's hook. And then the agent gets nudged to look at that hook. I don't know if this timeline feels that convincing. uh, like I said, as I was trying to read it out loud, I was like, huh, is that really the order in which things happen? Um, in which it happens? It seems like the agent would be executing before the convoy is created, which is weird. Maybe weird, right? Because as we mentioned, convoys are groups of tasks, right? Wouldn't that have happened like a lot earlier? Like if the once the molecule was created, um, potentially it would be grouped, depending on how this convoy is getting used in this context. Okay, so you find a session, you select the formula, you create molecules in convoys, right? You nudge the session and then you log the event, possibly in parallel. It's not clear from this uh, whether there is a intended sequence of events. Yeah. But I do buy that it is made up of these other things that have already been defined. Health Patrol. Um, Probe sessions, compare thresholds, publish stalls, and restart with back off. So, we don't know too much about the Health Patrol. We haven't really seen it in action yet. But I think the idea of it generally is that there are agents that go around checking on other agents to make sure that they're continuing to make progress, or that they're doing their job, or that if they failed their job, they get cleaned up, that kind of stuff. We look at the session primitives to see if they're alive. We look at config to see thresholds and backoff parameters. We haven't seen much of this yet. This is like infrastructure that was below our notice when we were learning the tutorials. And then publishing stalls, which presumably other people will respond to on the event bus. Okay, layering invariants. There are no upward dependencies. Layer n never imports layer n plus 1. Well, I guess that makes sense if you think of uh, if this stuff, these primitives are the first layer, it's true that they don't import anything from in here. Everything in here is built on top of these. But the numbers are sort of, the numbering scheme is weird, as I mentioned. Ease is the persistent substrate. Check. Event bus is the observation substrate. That's a good way to think about it. Config is the universal activation mechanism. That's an interesting statement. The only way stuff gets activated is through config. All the agents are defined there, all of the schedules and orders, uh, all the sessions are available, that kind of thing. All right, first time chatter. Unacceptable. Sorry. uh, all right. It's probably a robot too, so you know what. Side effects are confined to layer 0. That's an interesting statement. I wasn't expecting that. Um, is that true? Side effects are kind of a big topic, but the basic idea is that I would say that things like messaging were a side effect. I mean, clearly this is causing, these are causing things to happen. uh, this is an interesting statement. Say, in what sense is this true? There are lots of possible side effects for any process. Usually, when we're talking about side effects, in a very broad sense, we're talking about things that happen while something else is happening. And so, like, for instance, if I had, let's go back to our function to add x and y, right? Um, so, a purely functional way to add x and y, um, it has no side effects. It just takes x and y, it adds them, and it returns the result. It requires no state. It neither reads nor writes it. Uh, it doesn't have any side effects. It just does its one function, and then it can return it. And there's a lot of useful things that come from that style of programming. Like, it's impossible for a long series of such functions to kind of mutate the state or affect the universe in that way. I mean, there are such things as pure functional data structures, but you sort of have to bend over backwards to use them. Uh, but yeah, it's a lot easier to reason about something that's a pure black box that's just doing compute. But suppose that function did something like uh, it would add x and y, and then it would store that x and y in the database, um, and then it would return x plus y. Um, the side effect there could cause the function to like fail, like say the database isn't available, or it's unable to write, or something like that. Um, or you could have a lot of processes all trying to write the database at once because they're all adding things, and it's harder to reason about the impact of that function. Number one. Number two, say that it's incrementing, say, the number of times that the module was used, right? The number of times that function was called inside of the function. That's another kind of side effect. That's like causes all of the users of that function to have this sort of shared state. And that would be another sort of side effect. And so side effect is sort of a really broad term that could be used in a lot of different ways. Um, this side effects related to I/O. In this programming context, we'd usually be talking about reading or writing files, making network calls, like calling a remote system for data, or receiving back data from the remote system. We'd be talking about working with devices, telling the printer to do something, uh, sending stuff to the monitor so that you can look at it. Those are all sort of examples of I/O. Process spawning. This would be like starting a new program running. Uh, and it's not, I think, immediately obvious how um, we can sort of say that side effects are confined to layer zero if you say that, well, everything on the above layers is just made out of layer zero. And so everything of importance is happening in layer zero. But if so, it's kind of a tautology. If not, if everything of importance is at layer zero anyway, and all upper layers use layer zero. Why is this helpful to know? Um, Maybe it refers to the implementations at derived layers not adding any of their own side effects. But yeah, We might be able to read as we get into the detailed design documents. We might get more into that too. The controller drives all SDK infrastructure operations. No SDK mechanism may require a specific user configured agent role. I think this is an interesting way to think about it is that there are operations that are happening up in the user land and there are operations that are happening down in the SDK. Um, and you could say that I don't want a critical gas city process to crash or not work just because the user doesn't hasn't configured a certain role, right? So say that you wrote in uh, this particular process is going to be handled by a super bulldog or whatever, which is a certain sort of agent that's been configured in a certain way. But a lot of users haven't got a super bulldog inside of their city because that's a specific user configured agent role. Um, those cities won't be able to take advantage of that mechanism, right? That would be wrong. You want to be able to ensure that all of the standard operations inside of the city are covered with no additional configuration necessary. Okay, dokie. Here are progressive capabilities. So this is the 0 through 8 thing. I don't know if we're going to be able to make much sense of this yet. Um, but I think it's referring to building things in layers. If we had the workspace and agent sections only, then we'd be able to have this. If we have the daemon, then we'll have a controller kind of running our gas city for us. If we add configured agents, if we add mail, I don't know exactly what the leveling means, if it's like precedence or if it's just listing all of the different layers that might be in the configuration. And we'll go learn about them in all of those different detailed design files. But in what sense is this progressive? Add more information about how the layer precedence or ordering or dependency matters. And yeah, hopefully as we get into the documentation more, as we look into these designs and that kind of thing, maybe this will become really clear and we'll go, oh yeah, I guess you do need to have all of these things in order to get the next layer up, that kind of thing. Cool. Well, so we went through the 9 concepts document of the architecture. I think that was helpful, hopefully. Hopefully it was helpful for you, it was helpful for me, certainly. We got a few more pieces of feedback to give to these different documents. We did talk quite a bit about the bidder lesson. I think that's a really good general principle that we want to keep in mind as we're working with these systems. That the systems are coming, they're improving, and we haven't seen sort of the end of that curve, that power curve yet. We haven't seen anything plateauing. On the contrary, you can read a lot of news stories about how mathematicians surprised that things suddenly useful. You know, they seem to be getting smarter. They seem to be getting more time horizon on the tasks that they can complete. Of course, lately in the news, right? The Mythos computer finished a hacking challenge that is, at human level essentially. We're finding all kinds of bugs in our software, you know, and they're sort of spoken with an air of surprise, right? You know, we had no idea that we knew that they were cool and that they were doing things, but we didn't know that they were coming for our profession, for our specialty. We didn't know that they would be able to get this far. We thought they would plateau before now. And so when you read such stories, think about the sort of statements you'd have to believe to be surprised again by this bitter lesson. uh, I guess that I'll leave you with that. I hope you all have a really pleasant evening. Yeah, the video is going to get to YouTube. Again, I haven't tried to like edit these down for highlights or anything like that. Can you imagine anything more boring than listening to me talk again? So, I hope you all have a good night.